Hey guys, welcome to Question Mark, and you are watching the first episode of Destination Space. And today we are focusing our attention towards the friendly neighborhood star of the solar system, the Sun. The Sun is a star at the center of the solar system. It is nearly a perfect sphere of hot plasma with internal convection motion that generates a magnetic field via a dynamo process. It is by far the most important source of energy for life on Earth. And that's why you always find in textbooks that the sun is the ultimate source of energy. Its diameter is about 1.39 million kilometers, or about 109 times of the Earth. So it's the Earth's diameter, that's 12,786 into 109, and you would get the sun's diameter. And its mass is about 330,000 times that of Earth. It accounts for about 99.86 of the total mass of the solar system. Roughly 3/4 of the sun's mass consists of hydrogen, that's approximately 73%. The rest is mostly helium, approximately 25%, with much smaller quantities of heavier elements including oxygen, carbon, neon, and iron. The Sun is a G-type main sequence star based on its spectral class. As such, it is informally and not completely accurately referred to as yellow dwarf, because actually the Sun is more in a whiter shade than in the yellow. Of course, the Sun you are seeing is based on the combination of the ultraviolet as well as the visible light spectrum. But in the visible light under the solar filters, you can see Sun as a white star. It was formed approximately 4.6 billion years ago from the gravitational collapse of matter within a region of the large molecular cloud. So this is actually the theory behind the beginning of the solar system, known as the nebula theory. And yes, Sun is also formed out of that nebula 4.6 billion years ago. Most of the matter gathered in the center were the rest flattened into an orbiting disk that became the solar system. The Sun currently fuses about 600 million tons of hydrogen and helium every second, converting 4 million tons of matter into energy every second as a result. So Sun creates more energy than all the nuclear stations of the Earth combined, and that too in 1 second. The Sun's magnetic field, the Sun's gravitational pull, the heliosphere, they all are extremely big. The Sun's magnetic field even results in the constant pressure on the planets and other celestial bodies in the form of the solar wind. Sometimes we even call it as a solar storm. The solar flares is what actually causes solar storm, because it, along with many smaller parts of asteroids, hits the planets and maybe even destroys the magnetic field. In case of Mars, it's the reason behind the destruction of atmosphere and the magnetic field. The Sun's corona, or the most outermost layer, is not visible to the human eye until the total solar eclipse. So we had the total solar eclipse, or more accurately the annular solar eclipse, on this 26th December, and you can view the photos on the screen currently. That was, I personally was present and I observed the Sun, and it's even in the eclipse phase, it's not easy to observe the Sun. We need to have precautions by the solar filters and etc. The Sun, if you feel that the Sun is big, then Sun is a G-type main sequence star, as I already told. It's very small. It's a white dwarf or yellow dwarf, to be accurate. The English proper name Sun developed from Old English sunny and may be related to south. Cognates to English sun appear in other Germanic languages including Old Frisian, Sunne, Son, Old Saxon, Middle Dutch, Old High German, Old Norse, Gothic. The Latin name for the Sun, Sol, is not commonly used in everyday English. Sol is also used by planetary astronomers to refer to the duration of solar day on other planets, such as Mars. The related word solar is the usual adjectival term used. in terms such as the solar day, solar eclipse, and the solar system. The sun has an absolute magnitude of plus 4.83, estimated to be brighter than about 85% of the stars in the Milky Way, most of which are red dwarfs. The sun is a population 1 or heavy element rich star. The formation of sun may have been triggered by shock waves from one or more nearby supernovae. This is a suggestion this is suggested by high abundance of heavy elements in the sun, such as gold and uranium. Relative to the abundances of these elements is in so-called population 2, heavy element poor stars. The heavy elements could most plausibly have been produced by endothermic nuclear reactions during a supernova or by transmutation through neutron absorption within a massive second generation star. The sun does not have a definite boundary, but its density decreases exponentially with increasing height above the photosphere. For the purpose of measurement, the sun's radius is considered to be the distance from its center to the edge of the photosphere, the apparent visible surface of the sun. By this measure, the sun is a near perfect sphere with an oblateness estimated about 9 millionths, which means that its polar diameter differs from its equatorial diameter by only 10 kilometers. The tidal effect of the planets is weak and does not significantly affect the shape of the sun. The sun rotates faster at its equator than its poles. This differential rotation is caused by convective motion due to the heat transport and the Coriolis force due to the sun's rotation. The sun is composed primarily of chemical elements hydrogen and helium. At this time in the sun's life, they account for 74.9 and 23.8% of the mass of the sun in the photosphere respectively. All heavier elements, called metals in astronomy, account for less than 2% of the mass, with oxygen roughly 1%, carbon 0.3%, neon 0.2%, and iron 0.2% being the most abundant. In the 1970s, much research focused on abundances of iron group elements in the sun. Although significant research was done until 1978, it was difficult to determine the abundance of some iron group elements, example cobalt and manganese, via spectrography because of their hyperfine structures. The enormous effect of the sun on the earth has been recognized since prehistoric times, and the sun has been regarded by some cultures as a deity. Even in our Hindu scriptures, we refer sun as a Surya Devata. The sun has been an object of veneration in many cultures throughout human history. Humanity's most fundamental understanding of the sun is as the luminous disk in the sky, whose presence above the horizon creates day and whose absence causes night. In many prehistoric and ancient cultures, the sun was thought to be a solar deity or other supernatural entity, as we already discussed. In religions such as Hinduism, of course, the sun is still considered a god and we believe in it. The Egyptians portrayed the sun as god Ra, as being carried across the sky in a solar bar, accompanied by lesser gods, and to the Greeks, he was Helios, carried by a chariot drawn by fiery horses. From the reign of Elagabalus in the late Roman Empire, the sun's birthday was a holiday celebrated as Sol Invictus, soon after the winter solstice, which may have been an antecedent to Christmas. Regarding the fixed stars, the sun appears from Earth to revolve once a year around the ecliptic through the zodiac. So the ecliptic is the plane through which all the planets and the sun rotates around in the celestial sphere, and the zodiac stands for the 12 zodiacal constellations in which the sun passes in a year. And so Greek astronomers categorized it as one of the 7 planets. The name of the days of the week after the 7 planets dates to the Roman era. So defining the 7th day of the week as Sunday. In the early 1st millennium BC, Babylonian astronomers observed that the sun's motion along the ecliptic is not uniform, though they did not know why. It is today known that it is due to the movement of the Earth in the elliptic orbit around the sun, with Earth moving faster when it is nearer to the sun at perihelion and moving slower when it is farther at the aphelion. The sun's observational history goes back, and most common or the most respected discoveries is the sunspot by the father of observational physics, Galileo Galilei. Through this, we conclude our video on the sun. Thanks for watching, and tune in to watch the other episodes of Destination Space which are coming up soon. Thank you and have a nice day.